So once again, thank you all for taking time out for this very interesting topic. You know, you're going to hear a lot of different consultants and people in the space talking about the smart factory, the networked factory, but they all come back to probably the most prevalent concept, which is called Industry 4.0, right? We've now reached an area with computational processing power and network connectivity, et cetera, where it's opened up a whole new realm of opportunity for productivity, for efficiency. And I think what I'm hearing more and more from customers too, automation, given that so many organizations are really being hit hard by the struggles with regards to workforce. Right now in Wisconsin alone, if every person who was unemployed was placed into a job and was magically trained and motivated to do those jobs, we'd still be almost 87,000 people short in the state. And I know the same thing's replicated in Illinois and Minnesota, and well, pretty much in almost every state across the country. So how do we take this new, these new specifications and standards, new levels of interconnectivity to get all these components to now talk with one another? How can I send a message from my PLC that's telling me that I'm having issues on this component so I can get it to a preventive maintenance engineer to go and address that? How can I maybe use an AMR, automated mobile robot, to go and do tasks that I once needed a person to go do, and be able through my software to notify the robot to go and do that task? How do I increase the productivity while reducing the training time of my folks in the manufacturing process or in distribution or retail? Maybe I provide them some special goggles that allow them to use augmented reality. But once again, all of that requires interconnectivity that is scalable, that's flexible, and that's resilient, right? So particularly in manufacturing, where we're running 3 shifts, you know, most of the time 365 days a year now. So that's what we're really talking about. So McKinsey defines it, right, as the next phase of digitization, not just in manufacturing, but across the supply chain, right, driven by disruptive change, and that includes the rise of data, connectivity, analytics, human, machine interaction, and robotics. So we talk about 4.0. How did we get to 4.0, right? The first major evolution in the supply chain was utilizing steam-powered machinery. Then 2.0 was electrical powered machinery. 3.0, right, and this is the generation that many of us are still in right now, taking advantage of PCs and networking technology. But now with the new trends and capabilities, we're just stepping into the Industry 4.0 network. Once again, interconnectivity between devices, taking advantage of machine learning, AI, and so much more. So as we look at Industry 4.0, there's really 4 pillars, and we're going to be focusing on the unifying part of that today. So the first one is connectivity, data, and computational power, right? I don't know any enterprise these days that if they haven't already moved to utilizing some forms of cloud technology, they're looking and making plans to move to that shortly, to take advantage and leveraging the benefits of the computational power and storage that's there. Analytics, machine learning, artificial intelligence, right? A lot of that happening up in the cloud. Utilizing virtual and augmented realities and advanced engineering. So these are really the 4 critical pillars. And we do have a number of briefs, et cetera, that are available in the handout section that you'll find in the little control panel there that you have. But once again, what are the things that all of these pillars are dependent on? And it's the uninterrupted flow of data between all the various components. And so that's where we come today to discuss the connectivity. What are the requirements with regards to flexibility, scalability, security, and the resilience of a network? Because now, in the old days, right, I had my production machines and I just had to make sure those ran. But how do I leverage the intelligence that's being built into those and the network connectivity to really utilize or realize the benefits, as well as supporting AMRs, augmented reality, industrial visioning, robotics and printing, preventive maintenance, all those types of things. So right here in the center photo, you're going to see this is a young lady working at pulling raw materials at a manufacturing facility using a little headset that provides her augmented reality. So as she's picking from the bins, it automatically identifies which bins are before her, tells her which bin she needs to go and what quantity to pull from there. And then as she turns it around to put it on a bin, it tells her which bin to put it to, and it's automatically taken off to the workstation where those raw materials are needed. Once again, reducing the amount of training time that's needed and increasing accuracy and improving overall quality control. So those types of things. So in the early days, with the challenges we had with traditional wired and wireless networking, right? In the early days, yes, we built physical production lines that were stationary, didn't require a whole lot of flexibility. We ran one type of product with minimal modification to it through that production line. Today, things need to operate 24/7, 365, but I do need to have the flexibility of moving around different components to meet the evolving needs and changing products that that product line needs to support. So once again, early challenge of traditional networks, I have fixed position infrastructure that was rather laborious to modify and didn't make it easy to reconfigure my manufacturing line. The growing complexity of the LANs and all the different protocols that were needed to make sure that I had some level of resilience in the system, and some of the security constraints that are tied to traditional layer 3 networking technology. And then once again, boy, if I had a dollar for every time I had a manufacturing partner that was reconfiguring how they were cabling their manufacturing plants, whether it be overhead or in floor, the number of dollars that were spent for that is really tremendous. So those were the challenges we were always seeing, right, on the wired side. On the wireless side, and for many of you, we've been doing this with some of you, been of our partners since before Wi-Fi was even around, right? So we're in at the early days of that. We started off with 900 megahertz direct sequencing spread spectrum technology, pushing data to screaming 230 kilobits per second. Then we developed that direct sequencing spread spectrum radio into what we now know today as the Wi-Fi standard, and we got 2 megabits per second with 3 non-overlapping channels, and we thought that was the cat's meow. But as we tried to do more and more with that, we saw the limitations. In the upper right-hand corner right now, you see an AMR, right? It needs to constantly be in communication with its controller. If not, like any AMR, right, it's going to stop everything on the system for safety reasons. So I'll share one instance where we had a large manufacturing partner that was using AMRs, and everything would suddenly grind to a halt. And in one instance, it was because somebody had installed some microwaves nearby, and they operate near the 2.4 gigahertz range. And when they were going to warm up their meal right before lunchtime, it created enough interference where we were seeing latency of 350 to 500 milliseconds, right? Which is more than enough to halt the entire production line. We had the same thing happen with 2.4 gigahertz cordless phones, and even cordless scanners that you see there right at the bottom. So that interference added to the latency, which was just causing production to grind to the halt. We tried to overcome it by adding more access points and making smaller ranges, but once again, we're constrained by the 3 non-overlapping channels we had, because whenever you had a device that could talk to an AP on this one channel and a similar channel over here with a similar signal strength, everything would go into a roaming lock is what we call it. Once again, bringing everything to a halt. So we went from 900 megahertz to 2.4 gigahertz, and once again, we saw the limitations there with regards to speeds, channels, and interference. Then we finally got 5 gigahertz, greater speeds, more channels, limited to no interference, and but we still had an issue with cell size coverage, right? 2.4 would just cover so much more. Well, now with today's technology, we're seeing 5 gigahertz give us similar coverage to what we had with 2.4 just a few years back. They're still not equal, but it's pretty darn close. And now we just recently, with the 6E standard, got 6 gigahertz channels. So right now, on my 2.5-year-old Samsung phone, I'm connected at 2.4 gigabits per second. Imagine that, 2.4 gigabits per second. So it's really transformed what is now possible wirelessly, as well as with that, the requirements of wired infrastructure to things like access points, et cetera. So once again, with the new standards, 5 gigahertz and 6 gigahertz, we're seeing incredible low latency, greater throughput, and the resilience has just gone through the roof because we no longer have to worry about interference. And even for those of you that, once again, do require the highest levels of resilience and access points today, we're seeing them being able to be powered via PoE through 2 ports. So if one switch goes down, the access point remains up and running through another switch, getting its PoE from that other switch as well. So once again, a complete game changer with regards to what we're able to do. It really being able to take advantage of the principles of Industry 4.0. So just one little tidbit here I wanted to share. 2.4 gigahertz in almost any environment these days really no longer has a home. We're only recommending that in very few use cases these days. So for those of you looking to upgrade, et cetera, you really should be designing for 5 and 6 gigahertz moving forward, if you have the ability to. Once again, we're just seeing an overwhelming explosion of mobility products in the ecosystem for Industry 4.0. Up here in the left-hand corner, you're going to see a networked torque wrench. Once again, it was in the early days, they were only available with 2.4 gigahertz, and we would have issues once again due to latency and interference there. But now they're being designed with 5 gigahertz and soon 6 gigahertz, 5 and 6 gigahertz enabled radios inside of them. So you could have a number of these up and down the product line, your production line, and not see any latency. All right. So once again, get rid of all the safety hazards associated with those being wired in. And getting the efficiencies of having a cordless device up and down your production line. AMRs, we're starting to do more and more of that. Zebra Technologies purchased Fetch and a number of others. So we're starting to provide those solutions to our customers as well. Once again, helping to alleviate the workforce shortage burden by doing those menial tasks that we can do with AMRs. So once again, improving productivity and reducing costs as part of Industry 4.0. Fixed and, mobile, as well as pocket mounted wireless printers, your production boards and on boards out there going wireless, your lighting signals, mobile carts, even the PLCs these days, a number of them are Wi-Fi enabled now, being able to take advantage of the wireless network. So a whole new world of what is possible, which once again wasn't available before due to some of the networking limits that were imposed upon us, no longer hold true today. So once again, to sum it up, traditional challenges with the networking, wired networking, fixed cable infrastructure, growing complexity of needing to manage all these protocols to get the data where you need to, when it needs to be there, with some level of resiliency. A lot of that complexity with today's technology has gone away. Greater security today, et cetera, costly overhead and in-floor cable management systems. With regards to the wireless, we've been talking about it, right? Latency and limited bandwidth were really the things holding us back. And that was caused by limited channels, the impact of interference, limited hardware resilience, and limited coverage area. And today we're able to address those and more and meet the founding principles of Industry 4.0 with networks that are self-healing, that are resilient, that are ultra secure, that are able to provide both wired and wirelessly low latency, incredibly scalable and flexible, while still providing a level of mobility to your production lines and throughout your logistics for Industry 4.0. So really excited. It really is a whole new world that we're looking at today. So with that being said, I'm going to go ahead and turn things over to our technical expert from Extreme, who will go ahead and show some of these technologies that I'm discussing today that are really taking advantage or removing the limitations we had before and taking us into an environment where we truly can support Industry 4.0. So Mike, let me go ahead and turn it over to you.
Perfect. Thanks, Darryl. Appreciate that. Great insights on the previous and future of where things are going. And we're going to kind of hit that a little bit harder on how to build resiliency in the wired world today, as well as then layer on top some of the enhancements of Wi-Fi 6, Wi-Fi 6E. Not going to talk about Wi-Fi 7 today, but that is on the future horizon. And yeah, we can go from there. So if you want to hit that next slide for me.
Sure thing.
So the extreme way of doing things, right? New ways, better outcomes, right? We have our fabric switching technology, which allows us to scale rapidly as well as deploy easily, right? Those are two terms that really don't go hand in hand. With Extreme Fabric, we really bring those closer together, right? We talk about infinite scale, infinite growth, the ability to add 1, 2, 3, 4, 5 switches, 1, 2, 3, 4, 5 access points to scale the network out very easily, very simple, as well as our orchestration tools around it, right? We have one network, one cloud, one Extreme. We bring all of our technology under the one umbrella. So for licensing and pieces, right, it's a seat license. The seat can be an AP or a switch. Doesn't matter which model it is. If you want to go on-prem, on cloud, pick your poison, right? We're able to do everything from end to end with one license. We'll hit that next slide. So let's talk about why we make these investments, right? With Extreme or with any networking challenge, right? Budgets are a big concern. Network complexity is also a big concern, right? You can't just go off the street and hire somebody who knows everything about your network, right? There's multiple systems in place. We try simplifying that, right? We give you the option of training certification that gets you up to speed on our products, as well as partners like AWI who can handle the implementation, training, handoff type documentation, or we have at your own pace training that you can sign up for and learn everything from soup to nuts about the fabric technology, wireless technologies, all of those pieces. What Fabric brings to you, though, is it allows you to extend services across end-to-end networks. Doesn't matter if we're looking at that torque tool that Darryl talked about earlier. How do we onboard that easily? How do we make that where it works wherever in the plant we're at? How do we add more torque tools? How do we add other pieces? We give you all those functions and options so that you can have a zero-touch piece of networking where it sees it's a torque tool and boots up and pulls the right VLAN from the network. Could it be wired or wireless? Absolutely. What if I need to add 20 more torque tools? What if I want to simplify and add MAC addresses as the authentication source instead of a torque tool LDP signal coming through? We give you the flexibility to do all of that. Anyone hit that next slide for me? I like talking about this piece here because it hits home, right? ESG Research did a kind of a back-end survey that said, what are our biggest struggles with the network, 2021, 2022? Budget's always number one, right? I think anywhere in the enterprise world, government world, budget's always forefront of mind today. What do I get when I spend money? The second piece, right? Challenges in implementing security. It used to be functionality and feature. Security has now jumped that, and security is now the number one concern. We would say, for example, an average network spend may cost you $100,000. A security breach would cost, on average, 10 times that, $1 million. So investments in security are the focus. They really have been the focus over the past 3, 4, 5 years of both wired and wireless technologies. Then we jump down to what, 1% behind, but still close. Difficulty in provisioning network services, network performance, and then again, skill set, right? All within that 20% range. Very, very still front of mind of that. I always say challenges, the survey is challenges based on, is it matter to you 1 to 10, where does it matter? So they're kind of weighted against each other. So it's not going to equal 100%, but it's kind of like I compare it to a Yelp review, right? It's very hard to get 5 stars or anything because there's always these pieces that require those items. So in the network world, right, I would say budget's 5 stars, security is 4, and everything else can be underneath. But those are the 2 biggest concerns that I run into today. Next slide. So how do we do this, right? Single fabric, single control plane. What that means is the switches know they're switches. So you plug a switch into a switch, it knows it's a switch. That allows us to then expand rapidly, right? Switch A to switch B to switch C even back to switch A now gives you a valid link. Within Fabric, there are no loops, there are no spanning tree issues. Everything knows it's part of the cohesive Fabric core. It runs off an 802.11 standard, so that 802.1 AQ, I believe it is, or AJ for the Fabric technologies. Not something Extreme is doing proprietary. We just orchestrate and onboard and scale with some secret sauce we have, the value play of Extreme. We do that really well. And that's the reason we are so high in our Gartner Magic Quadrant slide, is that we are the only ones with auto self-forming fabric there today that doesn't require a third-party orchestration, a VM, or something else. All of it knows itself within the box, right? 2 boxes together, you have a Fabric core up to 512 within one area, and then unlimited areas from there. So infinite scale. Instant actions, right? Instant actions, auto provisioning, right? So that builds that piece there. Once the Fabric core stood up, all you're doing is changing edge ports. You don't have to worry about trunks or pieces between switches, right? I don't need to worry that if VLAN 34 is the access point at the edge, that every trunk in between has it. Those are automatically self-forming. So all I'm doing is changing the edge port, and the rest of the Fabric knows about it. And then protecting the network, right? Fabric encapsulates every type of packet again. So it's adding another layer of encapsulation encryption to each packet throughout the network, so that if you are able to breach the network somehow, it's a ship in the night. You can't see that because of the encryption. We have a hackathon every year, and the prize has gone up $25,000 to hack the Fabric. We literally give you all the information, the gateway, everything but the admin passwords. Try breaking the protocol. We're on year number 7, just happened last week at our Extreme Connect. The bounty is now 200,000. So every year it increases 25,000. We're going on year number 8 where no one has been able to breach this. Next slide. So what do we get, right? So anywhere services, campus, SD-WAN, branch, we combine remote sites, local sites, all into one Fabric. Unified services, right? Everything runs in the same protocol across those pieces. You plug an AP in, it knows Extreme AP, it knows it's Fabric aware, pulls its configuration down. Plug and play deployment, right? The joke is once you've got the 2 boxes set up, it will take you longer to unbox, rack and stack, plug the cables in than it will to actually make it part of the Fabric. Highly scalable segmentation and stealth, right? We talked about that. Ships in the night. I can't see one or another unless I'm joined to that same VLAN, which is going to be a layer 2 type connection. If they're tagged correctly, I can share. If they're not tagged, I don't see anybody. A fun fact about Extreme Fabric, it is the only certified technology in the state of Nevada for the Gaming Commission that allows you to run casino operations, slot operations, back of house operations, hotel operations, and hospitality on the same switch. Otherwise, all of those must be physically segmented on switches because of that. The MGM hack, the Caesars hack. You didn't hear the word win in there. The win is a Fabric customer of ours that we proudly share. They share our technology. They did not get hacked. They had the same attack vector, same exploit run, but since they couldn't jump or couldn't see other items, that was prevented entirely. Next slide. So you're going to hear on the Extreme world something called universal hardware, universal switches, right? Our 5000 series and 7000 series are universal. You can run traditional networking or Fabric networking, switch the persona of the switch. Once you're in the Fabric world, 2 switches you build as a core, you run through a wizard, answer a few questions, builds the core together, and then literally you're just starting to plug switches into each other, and they are all self-forming. In the lab that we do, or the demo we do, in a classroom environment, we have six switches that we then will just provision ports across the 6 switches in a matter of seconds, and I can communicate from each station to each station with whatever port I provision automatically. No secret sauce. It's just built in the wizard, built in the protocol, built in the OS itself. And then layer 2 and layer 3 in multicast, right? For example, multicast will flood a switch and say, hey, who's a receiver? Let me receive this piece here. With Extreme Fabric, if that switch port is not part of that multicast domain, doesn't see the traffic at all, right? It's dropped like a switch comparatively to a hub. It just drops it. But if I have a port that receives it, then I'm only taking that multicast traffic and adding it to one port or subscribing it to one port. So now you don't have to worry about PIM domains, sparse domains, any of that type stuff for multicast across the network. You just have to have it within a port profile that, hey, here's the multicast VLAN. I'm a part of it. Add the receiver. It's a template. Apply the port template, and it will only route to the one port. Keeps bandwidth on the back end very low for multicast. Next slide. So what's this look like, right? Just reinforcing what we went over, right? Controllerless design, service enabled by provisioning only the edges. So again, if I need to add a new VLAN across the entire network, I never have to put a service request in for potentially modifying a trunk port and bringing networks down. Never touching the trunks. So in the hospital world, in the enterprise world, in the manufacturing world, I need a change window usually to change a trunk or add a VLAN to a trunk or remove a VLAN from a trunk. In this setup here, right, I don't need any of that. I'm just changing an edge port and hitting go. No core config is changed so that I don't have to worry about a change window. Don't have to worry about that. All low risk. All of our manufacturing and hospital customers who must be up 24/7 go to a no change model with this because of the reliability and what the code's actually changing. Nothing on the back end, just an access port on the one side. Core and aggregation nodes, right? It's all one and the same. We talk speeds and feeds. How fast do you want to go from core to edge? 1 gig, 10 gig, 25 gig, 40 gig, 100 gig. Pick your piece there, plug the cables in. It assigns like an OSPF type route limit to that, right? So eliminates hop by hop provisioning, but I do get a link between, switch A and switch B is cost 1, or actually cost 10 if it's 10 gig. If it's 100 gig, it's cost 1, and the next hop will calculate that. So as I'm adding nodes to my fabric cores, it will automatically calculate all the potential routes and weights on them to give you that piece. If a node is unplugged or I lose a link, it will fail over within, I think, 13 milliseconds, full reconvergence time, because all those routes and weights are already pre-generated. So you won't even drop a phone call. You may miss a word on a phone call, but that phone call will automatically redirect through the fabric, giving that high measure of resiliency. One of our other customers is the Indiana Toll Road, and they have a big ring, right? When they lose a node on a ring or something happens, their cameras go down for 60 milliseconds and then come back online. So you lose a blip and it comes back, boots up, and now you're using another route immediately through, I think, 34 nodes in a ring. Next slide. So what's it look like, right? Everything's encapsulated again with an ISID tag, it's called. So what that does is says, hey, my ISID tags, I'm going to subscribe to a application, a tablet, a PC, a security camera, a torque tool network, whatever you'd like to be, right? Your scan guns can be on their own network. They don't see anybody else within that fabric. So it comes in the fabric, gets encapsulated, ends up where server it needs to be on throughout, right? In here, you can see toward the bottom right, they do share a switch port on there. I wish there were more lines that connect, so you can see they're using certain routes to certain applications. But in most use cases, right, all the switches will come back to an IDF or MDF. That server room will be in there. All the servers are on the same switch, so they end up on the same switch, but they're all secure virtual segments, right? I can have 45 VLANs on that switch, each going to its own application, and then each device on the end can only talk to its own application. Do you want applications to crosstalk for sync and pieces? Sure, absolutely allow that as access rules. Nothing crazy. It's all there. And again, those segments extend wherever there's fabric. So they're automatically extended to the edge switch. They don't become active until you build a port for it. So for example, if I'm flooding multicast traffic out, all those switches say, I have no subscriber ports, drop this traffic at the switch. It'll never get to the edge and keep that bandwidth low on those trunk links. And then security or resiliency, right? Any switch node can fail to any switch node. It doesn't matter, right? I don't need to worry about a loop. I don't need to worry about missing VLANs on trunks. I can cut the cord and let it fail over to another one. It'll automatically work. Plug it back in. Cool. There it is. Oh, I see that I've got a lot of bandwidth coming from access switch 3 to my core stack, and I want to say, yep, I want to go ahead and add more bandwidth. Well, cool. I'll take another XFP port. I've got 10 gig going today. Plug another 10 gig in, I now have 2 10 gig channels to that port, which will automatically load balance between them, saying, okay, now I've got 5 gig and 5 gig. I've got capacity on either. Next slide. Wi-Fi 6, right? Darryl hit heavy on this from going from 2.4 to 5 to now the 6 gigahertz spectrum, right? So Wi-Fi before Wi-Fi 6 was always a half duplex medium, right? I was able to only talk to or from one device at a time. With OFDMA and BSS coloring, I am, and actually downlink MIMO, we'll put that in together, those 3 pieces there. It now gives me an 8-lane traffic. When I say 8 lanes, I can either send on 8 lanes, receive on 8 lanes, send on 4, receive on 4, but I'm getting 8 times the throughput in that same Wi-Fi time window. And those time windows are very fast, right? Today on Wi-Fi 5, I can talk to 7, 8, 9 clients and no one even knows that there's a delay. When I start getting 25, 30 on a radio, there's going to be a little bit of delay. Now that I go forward to Wi-Fi 6, if all of my clients are Wi-Fi 6 on the edge, I can fit that 8 times the amount of traffic in that same time window. So I can scale immensely. It was very hard before on Wi-Fi 5 to push more than a gig of traffic through the access point. 600 mega radio, maybe at best, 2 radios, right? 600 meg, 800 meg, maybe 2.4 and 5, maybe 1.4 theoretical at perfect conditions. Ideally, you're going to see 600 meg total on the AP with those time windows. Now we can blow by that, right? Darryl mentioned on a Wi-Fi 6, not even on 6E yet, Wi-Fi 6 on a 80 megahertz channel, I can push 2.5 gig to one device. Or multiple devices at Wi-Fi 6. Higher data rates. Let's go past 2.5, right? We can go now on our high-end Wi-Fi 6E access points. I give you a 5 gig, a 1, 2.5 gig, and 5 gig Ethernet port, multi-rate to those devices, where I can now push theoretically 4.8 gig across the wire. When you're talking about Wi-Fi 7 going forward, our new APs planned have a 10 gig capable Ethernet port on there because we are seeing more and more and more speed improvements on that. And then target wake time, right? If you've got devices that need to wake up, shut down, do things like that, it's now all built in the protocol. So you're not doing a super crazy script to turn on, turn off things. We can just set target wake times on those IoT devices to wake up every hour, send some data, and then shut back down. So road signs, things that just need to report little weather sensors, need to report a little bit of data. We can do that all natively in the protocol. Next slide. So we go from Wi-Fi 6 to Wi-Fi 6E. The first Wi-Fi thing that does not a number upgrade, right? What 6E does is it gives us new spectrum mainly, right? I now get access to the 6 gigahertz spectrum, both indoor and as of July 1st, access to the outdoor Wi-Fi pieces for that. Allows us for enhanced traffic management, right? I get more information about the packets on there. Low latency and latency improvements, less overhead. As you might see in the next slide, right? 2, 4, 5, and 6 gigahertz spectrum radios. So in our AP4000s and our AP5010s, I give you a tri-radio. So still support for 2, 4, support for 5, and support for 6. Able to support the full spectrum. In our Wi-Fi 7 APs, we're going to a software selectable radio. So it's 2, 4, or 5, a dedicated 5, and a dedicated 6. So as Darryl mentioned, 2, 4 is going away. So I think as we go to Wi-Fi 7, we can still have support for 2, 4, but we can then also have support for 2 5 gig channels and then a 6 gigahertz channel to get you that best performance, right? Move the slider forward, move the slider forward, drop off 2.4 entirely, keep 5 and keep 6 in the network, but optimize all of that. More spectrum and cleaner spectrum, right? 6 gigahertz channels, 187 channels. I believe we get over 80 different channels on 20 megahertz, bond them together. We're now designing for 40 megahertz as a standard to get you those speed increases across the platform on 6 gig, easily 300, 400, 500 meg to each client available. I always say on 6 gigahertz, you're going to have a good time at this point because it bumps that floor up from the older protocols to only support AX, a la Wi-Fi 6 and newer. And then enhanced security, kind of a double-edged sword, right? How do I support WPA3 on 5 gigahertz and 6 gigahertz and 2.4 maybe? Well, today with older devices that are only 2, 4, and 5 capable, they may not have support for what's called WPA3 encryption, which is the new standard. If they don't have that, then they're kind of stuck on older. So we've got to support a 2, 4, and a 5 legacy network, where a 6 gigahertz can be a full clean network. As we start dropping those older devices off, so the ones that are only 5 gig but not 6 gig capable, but still have 6 gig Wi-Fi 6 capabilities, they can use the enhanced security as well. So it's about, when is a good time to migrate? When do I want to invest in pieces? That's where Darryl and his team come into play, where we come into play to start evaluating what devices you have that are legacy or older, do a little bit of analysis, and then come up with the best design for you guys. And I think there's one more slide. Yes, so just kind of reiterating what I said earlier, right? Some design advantages. The older radios need to support certain pieces. So for 6 gigahertz band, there's no RTS, CTS protection, right? So it allows you to connect with lower latency, right? Natively in the protocol, I know that now. I don't need to do extra compute for encryption. I know I'm there. 6 gigahertz frequency band will be a pure 802.11ax technology, right? So it drops off everything older and forces you on a newer play. Can it cause problems today? Yes. In 3 years, will it be a problem? No. But as we're in this lull of devices where I may have devices that are 7, 8, 9 years old, we still have to account for those. This is where we talk about planning with AWI and Extreme. 6 gigahertz band is also cleaner, right? So there's no dynamic frequency selection really requirements because there doesn't talk on the radar signal. So if you live near an airport, you get to turn off DFS channels in the Uni 2 section because radar uses those. 6 gig is nice clean air. And then once again, co-channel interference, right? All been eliminated because there's so many channels. 20 megahertz is the standard today when you want to plan for each channel use. We're bumping that to 40. I'm even sometimes bumping that in smaller environments to 80 or 160. Do I need 10 gig of bandwidth to a client? No, but can I give it? Absolutely with 6 gig now. I believe that's the last slide. So I'll open it up the floor to Darryl to mediate and answer any questions we have from there.
Beautiful. Well, thank you so much for that, Mike. Really appreciate it. You know, we've gone through an awful lot of information really quickly. So I want to give everyone an opportunity to ask some questions. So you'll see in your little control, remote control for GoToWebinar along the right-hand side, there's an area down there that says questions, and feel free to click on there and ask any question that you have. Oh, I have one here right now. I had a wireless deployment at a plant that used ultraviolet lights that emitted huge interference, 2.4. So had to go to only 5 gigahertz and increase the density of the APs. You know, that's not a surprise. We're seeing we've seen that for quite some time now. There's just so many things that emit interference in 2.4 that we really are pushing everything to 5 gigahertz. Now that with today's technology, we are able to cover some larger areas than it was able to cover before. As I said, everything from microwaves to phones to hotspots that people are having on their phones. It's a dirty space, right? Garage door openers, etc. Everything, there's so much that plays in that area, especially lower cost IoT based radios that you'll find in like vending machines that need to periodically phone home to say that they need to be refilled. It is just dirty air, right? So the more we can move to 5 gigahertz, and now the cleaner air we're getting at 6 gigahertz too, we're just seeing the ability to do so much more. We're seeing the low latency and the capacity bandwidth. And as Mike was saying, boy, the amount of data we're able to push through wirelessly these days, and the latency that we're seeing, the low latency, we're seeing so many devices move to that. The key thing is we keep having to remind people, you got to make sure you have the wired infrastructure that can support that as well. Because with the newer access points, in the old access points prior to AX, we would never go over a gig of true throughput that's going in out of the Ethernet port of the access point. Not the case anymore. So you got to make sure that you build out your wired network to be able to support that. So yeah, that is a very good point. Not surprised that you saw that. And we're working with all of our current customers really to move away from 2.4 gigahertz for that very same reason. Does anybody else have any questions about this, or the use of AMRs on a wireless network, industrial visioning, any of those other things? We have the experts here with us today, so now's the time to ask it. In addition to, in the remote control, you're going to see there's an area for handouts where you could download a variety of application briefs from Extreme and from Zebra, another one of our good partners on moving to Industry 4.0, things that you really should consider. When AMRs alone, we're seeing in a recent Zebra study, they saw 26% of all folks in logistics either had or were currently implementing AMRs throughout their facilities, with over 60% saying they were planning on doing so in the next year or two. So if it's something that you're thinking about, you have some questions, please feel free to reach out to us on that as well. So I'm not seeing any additional questions coming in. So Mike, I think you must have done just such a great job of explaining the technology, whether it's fabric and, really the mesh approach it takes. So there's no longer a single point of failure, and the ability to automatically increase bandwidth with, once again, having zero chance of creating a network loop. That is just huge to all of the new wireless technology and standards you're seeing. You did a great job. So if anybody has questions, you can always email us here at solutions@awimobility.com, or me personally at dmorin, DMORIN, at awimobility.com. Please feel free to go ahead and download some of the handouts. We'll also automatically email you a copy of the slides that were used here today. Just ask that you keep them in-house with your organizations and not to share them online. But once again, go ahead, enjoy another slice of that piping hot pizza on us. And thank you for taking time out of your busy schedule to join us today. Oh, and in the next week or two, we're going to be announcing some in-person events where we're going to be demonstrating a lot of this technology we're talking about, everything from the fabric to the wireless to AMRs, the automated scanning and industrial machine visioning, and so much more. So keep an eye out on your email for an invite from AWI Mobility in the not too distant future. Thank you all once again today, and have a great week.